All right, so I had mentioned in the last video that your input for an analog sensor is going to change based on the environment, right? So in some environments, that 0 to 1023 range, you might never see the full spectrum of it. You might only see like 0 to 850 or from 200 to 900. It really depends on the environment and the sensor you're using. So how can we deal with that? How can we write code so that it can adapt to a changing environment? What I'm going to show you is one way to kind of deal with that when you turn on your code and as it runs to dynamically adjust the range, your minimum and maximum values for a sensor so that its range will adapt to the environment in the sense that the range will get larger to adapt to the environment. With this code, the range is never going to get smaller for an environment, but as the range expands, it'll adapt to that. And I'm just going to walk you through this code so you can see how this works. Again, I'm going to be using the light or photo sensor on here and the LED as an output. So what have I got? I've got the library, I've got my LED pin, and then I've got two global integers called minVal and maxVal, and I've set them both to be 500, which is roughly the middle of that analog range. In my setup, I've got the pin mode for the LED, and I've got the serial begin, and then I've got a delay here waiting for that serial to connect. Is another way to do that. All right, then in loop, I'm reading that light sensor into a variable called photoVal, and I'm going to print that out, what the photoVal is. And then I've got two conditionals. One is if photoVal is less than my minVal, which we call as 500, then set my minimum value to the photoVal. Okay, so I'm changing the minimum as photoVal drops down the range. And that's it for that if. Then I have another if, and this is if photoVal is greater than maxVal, then set the maxVal equal to the photoVal. And so that's as the value of photoVal increases, increase the maximum with it. So that way, photoVal will always be between my minVal and my maxVal, which is important because we can tell with these being equal when we initialize the sketch, it's impossible for my photoVal to be between those two numbers. So this will ensure that my reading is always between my new minimum and maximum, but also that my minimum and maximum are appropriate to the environment that I'm in. I won't ever have a minimum or maximum value that is impossible to reach. And you can see on this if I've got a new way of doing this, right? So if I have a very simple if statement, if one condition is true, do one thing, I can put that all on one line without the curly braces and just end it with a semicolon. So then if I want to do something with that sensor value, right, I want to map it, let's say, to this LED, the LED is going to be the same, 0 to 255. That's what I want for my output. It's the input range that's different. So I'm saying in mapVal equals map my photoVal, which is going to be between my minVal and my maxVal, instead of between 0 and 1023. And then I've got a bunch of prints to print out, the mapVal, the minVal, and the maxVal, and then adjusting the LED. So let's take a look at that. And here we go. PhotoVal, MapVal, minVal, maxVal. So the maxVal hasn't ever gone above 500, so that might actually be artificially high. But we can see my minVal is 205. And so as the environment changes, I can adjust this, right? So if I throw some shade in here, we can get our minVal down to 3. 2. And if I move this close to that lamp again, we can get up to 964. And so now our range for this sensor, as I move my hand above it, is going to be more accurate to the environment that we're in. So when you're working with analog ranges and installations in interesting or dynamic environments, this can be a helpful tool to automatically adjust your ranges.